Hello geometry students, welcome back. We're still in section 7.1. We're going to be talking about reflections again. This is day 2 of reflections. So let's go ahead and let's graph the line y equals x. So if you recall from algebra, the line y equals x goes right through the middle here at a 45-degree angle. So it goes up here. If you remember, this is the first quadrant, and then it goes through here to the bottom left, and this is our third quadrant. Okay, and then we want to list 5 points on the line. So let's pick any 5 points. I'm going to pick this one, and this one. That's 2, 3, 4, and 5. So there's 5 points. So we've got this point here, which we notice is 4, 4. And then we've got this point here, which is 2, 2. And this point over here, which is negative 1, negative 1. And over here I have negative 3, negative 3. And then this one over here, I have negative 4, negative 4. So what do we notice? We notice that any point on the line, the y value is equal to the x value, which makes sense because we have the equation y equals x. So we want all the places where x and y are equal. So we get this line that cuts right through at a 45-degree angle on our coordinate plane. And we want to figure out what happens if I reflect over this. So you may have figured this out already when you did the last homework assignment, but let's take a look at a point. So I'm just going to get these out of the way just in this first quadrant. All right, so let's take a look at this point over here, 2, 3. Now, if you can visualize, if I flip this over the line y equals x, it's going to end up over here. So I'm going to make this A, and I'm going to make this A prime. So the point A, we just arbitrarily picked to be 2, 3. And then when we reflect A over the line y equals x, we got that A prime was 1, 2, 3, and up to 3, 2. A prime. So we see here that the x and y values are actually switching. So let's pick another pair of points, or another point, and reflect it and see if that also happens. So let's pick maybe 5, 3 right here. And let's make that B. So let's flip the other way. So here's point B, which is 5, 3, and let's go ahead and see if we can figure out what B prime is. So if I'm over here, I'm going to flip it over y equals x, so I should end up right about here. That would be B prime, so that would be 1, 2, 3, and up 1, 2, 3, 4, 5. So 3, 5. So again, we could see all we did was switch the x and y coordinates, and we get a reflection over the line y equals x. So how do you think we will graph a reflection over the line y equals x? By switching the values of x and y. Alright, so that's all we need to do. So again, it's a rule that we're going to have to try and remember or figure out as we go along. So let's take a look at this first example here. I can use an XY coordinate grid to model reflections. We want to graph the following image using the given transformation. So we want to reflect over y equals x. Okay, so we already figured out in order to do this, we're going to flip-flop the x and y. So let's start by figuring out what our coordinates are of our original points. So we've got point D here is negative 2, 4, negative 2, 4. So D prime, we're just going to flip those. It's going to be 4, negative 2. Notice the signs didn't change. The negative 2 here is still a negative 2 over there. All right, so then E we have 1, 1. So when we switch that, it's going to stay the same, 1, 1. And then r is -2, -3, -2, -3. So we'll switch those to get -3, -2 for r prime. And then our last value here is g, so that's -3, +2. -3, +2, flip-flop those to reflect over y equals x, so we get 2, -3. Alright, so let's go ahead and graph those. So let's pick red here. So we've got d prime is 1, 2, 3, 4, -2. So there's d prime. And e prime is going to be here also, so that's e prime also. E and e prime are on top of each other. R prime is -3, -2. So here's R prime. And lastly, we have g prime, which is 2, -3. So that's g prime. And then we'll go ahead and connect the dots. And let's highlight that just to make it a little easier to see. And I'm going to draw in the line y equals x just so we can kind of visualize. Here's the line y equals x. And if you kind of look, you can see that everything on one side has been flipped over to the other side of y equals x. So this dotted line here, this dashed line, is our mirror line that everything is reflected over. Alright, so what I want you to do is I want you to go ahead and pause the video. And again, we're going to do another example of reflecting over y equals x and see what you can come up with for part B. And then when you start the video again, we'll have the solution up there, and you'll be able to check and see if you did it right. As always, if you have questions, make sure you write those down, or if you happen to be watching in class, make sure you pause the video and ask your teacher. And go ahead and pause the video now, work out part B, and then when you restart, the solution will be here. Alright, so here's the solution for part B. You notice I've got all my ordered pairs here, and we talked in class that in order for it to officially be an ordered pair, you have to have the parentheses, so make sure you don't forget your parentheses. So we've got our values for P, S, and Q. We've got P prime, S prime, K prime, K, not Q, K prime. And then once I wrote my ordered pairs, I just switched the X and Y's and graphed them, and we can see that the line y equals x is going to be our mirror line. So we basically just flipped it over that line. So make sure you're careful, make sure you get your coordinates right, and then just flip them and redraw the new figure. Alright, so let's move on. So now we want to write a rule to describe the transformation. So let's go ahead and let's write the coordinates for P, A, and W. So on yours it's probably not in color, so be very careful to figure out which is the original and which one the image is. This one on the right, which on my screen here is black, is the original, and then the blue one on the left is the image. On yours they're probably both showing up as black, so again be careful, make sure you see the little primes in there. So P is going to be 2, -3, and A is going to be 3, -5, and then W is going to be -1, -4. Let's go ahead and do the same thing for P prime, A prime, and W prime. So P prime is -2, -3, and A prime is going to be -3, -5, and W prime is going to be 1, -4. Alright, so we can see right away hopefully you notice from the picture that this is not a reflection over y equals x, because if I had my mirror line going right through the middle here at y equals x, we can see that we don't have the same thing above the line and below the line. So we can hopefully see that if I draw in my mirror line right here at the y-axis, that this is a reflection over y equals x, and then all we need to do is come up with a rule. So if we take a look here, here's my values for x. We have 2, 3, and -1, and all of these change to the opposite. So here's -2, the opposite of 2, -3, the opposite of 3, and 1, which is the opposite of -1. So all my x's change to the opposite of x, and we can see that my values for y, those didn't change at all. So all my y values stay the original y values, and there's my rule. So we're kind of taking a step back. We're trying to mix all of our different transformations together so you don't lose track of any of them. Alright, go ahead and pause the video again and give this one a try. So you're going to write the coordinates for x, c, n, and p, and then x prime, c prime, n prime, and p prime. Hopefully you can get an idea of what's going on in the picture, of what it's a reflection over, and then you can write your rule for that. So pause the video now, work this out, and when you restart, the solution will be up there. So here we have the solution for the second part here. When you write out the coordinates for each, we can see that the x and y coordinates for each have just been flip-flopped. So here we had -1, 3, and then over here it's switched to 3, -1, and this pattern continues for all 4 of our points. So our rule, all our x, y values switched and became y, x. And again, hopefully you can see in the picture, if I draw in y equals x, you can see that the two images are mirrored over that line y equals x. Everything on the black figure that was above the line is now below the line in the blue, and everything that was below is now above, just this little triangular part. Alright, so the last thing here, composition of transformations. So this is a combination of more than one transformation. So when we say composition, don't get confused, don't get scared by that word. All it means is we're going to do more than one transformation. So maybe we'll do a reflection and then we'll do a translation. Okay, or maybe we'll do 2 translations or 2 reflections. Alright, so in the image below, what I want you to do is reflect the triangle over the x-axis and then reflect it over the y-axis. So your original is n, c, and z. So when we reflect it over the x-axis, it's going to be n prime, c prime, and z prime. And then when we reflect it over the y-axis, it's going to be n double prime, c double prime, and z double prime. So go ahead and do that. When you're finished, you can check in class to see if you did it correctly. And as always, if you have questions, make sure that you ask, get those questions answered before the next assessment. And we will see you in the next video.